Hello! In this video we're going to be looking at Bayes probabilities. Now I'm going to admit at first Bayes probabilities really freaked me out. Why is that? Well, there's a lot of this given that and unions and I don't know, it just used to freak me out. But it's really not that bad. Bayes probability is a lot like the stochastic stuff and some of the other things we've seen, in that it's just things that we've seen before a little different. And so Bayes probability is kind of a way to do probabilities in trees without having to draw a tree. You could solve most Bayes probabilities problems by drawing a tree, but this is much faster and easier, and if you're on a test they're going to want you to do it this way sometimes. That being said, there's never a problem with kind of getting your brain right, especially with these smaller ones, by doing it with a little bit of tree work. So I'm going to kind of show you both alongside each other. Bayes probability corresponds to section 3.4 in the book Finite Mathematics by Daniel P. Maki and Maynard Thompson. This is something you'd see about the midpoint in a finite course, and I know it's taught typically right before the big midterm at Indiana University M118. In this video, I'm going to be going over one of the recommended problems from one of the syllabuses one of the instructors gave us. Syllabi? Not really sure. Have to admit. We're going to go with syllabi. It sounds really swanky. And because this is IU, of course, I had to choose the basketball problem. So let's do our first things first. Let's read the problem, and then we're going to write down the important bits, okay? A basketball player is equally likely to make and to miss his first shot in each game. If he makes his first shot, then he is twice as likely to make future shots as to miss them. If he misses the first shot, then he is twice as likely to miss as to make future shots. Well, that sounds kind of crazy, but I think we can write this down in a way that makes sense. The question is asking, it's two parts. Part A, in a game in which the player makes his third shot, find the probability that he made his first shot as well. Well, we're going to ignore part B for right now. We're just going to do part A. So let's go through this and write down what we know. Okay, so reading the problem, I'm actually going to write this data down in the form of a tree. We're not going to use a tree to solve this, but I think it's a valid way to kind of write down what we know. And I hope it will kind of bring together this idea that Bayes' formula is just kind of an expansion of trees. That's not mathematically precise, but we're not worried about that right now. We're worried about just kind of getting a feel for it. And so you could solve this problem with a tree if you really, really wanted to. I wouldn't recommend it. It would not be fun, but you could. So let's go ahead and start writing some information down. So we know we have a basketball player, and I'm going to start by drawing an awesome basketball. Isn't that amazing? And he has two options from here. He can either make a shot or miss a shot. So I'm going to call this MK sub 1. And this just means it's at the first level. That's what that sub means. MS sub 1. So that's make or miss. And I'm doing that because otherwise this would be huge and there would be lots of words. And to be frank, I'm a little bit lazy. And so let's see. I'm running ahead of myself. He has equally likely chances to make as he does to miss. So that tells me he pretty much has a 50-50 or 1/2 chance to make any shot as he stands up on the line. So on the next level, we're going to go down this make tree. We're just going to focus on that right now. He could make it, and we're going to call this make sub 2. This means it's on the second level. Or he could miss it. This is miss sub 2. And here, if he makes the first shot, he's twice as likely to make that second shot, and he is to miss it. So that means 2/3 to 1/3. And if you're not comfortable with that, I would definitely recommend checking out some other videos. But we're going to move forward for right now. If he misses that first shot, then he has two more options, right? He could make it, and this is make sub 2. So this is still on the second level of the tree, but different than the first one. It's just for clarity on our part. And he could miss it, so that's miss sub 2. And here, if he misses the first shot, he's twice as likely to miss future shots than he is to make future shots. So that's 2/3 to 1/3. And that's kind of all the information they give us. So when he first gets up to the line, he has a 50-50 shot to make the shot. If he makes the shot, he's more likely to make future shots than he is to miss future shots. And if he misses that first shot, then he's going to be really bummed out, and he's going to be more likely to miss future shots than he is to make future shots. So how does this fit into Bayes' formula? Well, let's go over what Bayes' formula is first. So before we get too much further, we should probably talk about what the Bayes' formula is. And at its most basic form, I mean, if you go to the Wikipedia page, it is the probability of A given B equals the probability of B given A. This is why it used to freak me out. I'm going to admit there were a lot of givens, and I just wasn't really sure why. But it's not so bad. We're gonna figure this one out. The probability B given A times the probability of A over the probability of B. Ha! I made that one work. So that's the formula in its basest form. We're gonna break this down, and I'm gonna kind of talk you through how I fit everything in this. So for part A, what do we want? We want the probability that he makes his first shot, so we're going to call it make 1. Hey, see why we did that? Given that he makes his third shot. And we didn't go all the way down the tree, but if we were to continue down this tree, you know, this would be MK3 here, and you know, for every future shot, this stays the same. It's always 2/3 chance to make, you know, so if we could just keep going. We're not going to, because we're going to use the Bayes formula to do this. So this is how I think of it. I try to write it down in a way that makes sense to me. And so this is going to be the probability that he makes the first shot times the probability that he made his third shot over pretty much, and I'm not going to call this probability B, I'm going to call this the probability of making any shot. Actually, no, we're gonna even call it differently. We're gonna call it the probability he makes any make at level 3. Okay? And so hopefully that makes sense. Let's break it down. So the probability that he makes his first shot. Well, we know the probability that he makes his first shot, and that is 0.5, right? And we know the probability that he makes his third shot, P MK3, is let's see. The way we would figure that out, right, is that would be I'm not going to use points. I'm going to use fractions. This makes the whole thing much less annoying. So let's go ahead and back up. I'm sorry about that. So the probability he makes his first shot is 1/2. The probability that he makes his third shot is 2/3, right? And so what is the probability that he makes any bottom shot? And so let's go ahead and figure out that one, right? I'm going to call it any make 3. And this is not official math talk. This is how I solve the problems. This is how I think of the problems. So if you're a little freaked out about it, that makes perfect sense. We're going to do a couple of different ones of these. So check out a couple of different videos, and hopefully one of them will make sense to you and will fit, you know, will fit what you need to know, okay? And this is actually, yeah, that's what we want. Okay. So now we're going to do the probability of he makes any of the third shots. So that's actually a bunch of different probabilities added together. And so let's go ahead and break them down, shall we? So this might seem intimidating, but we know how to do this. And so let's break this down. There's, you know, there's a path that we need to find. So we need to find the chance that he makes on level 1 intersect with the chance he makes on the second shot intersects with the chance he makes on 3. What else do we need to find? We need to find the chance that he makes on 1 intersect with a chance he misses. Oops, that was a mistake there. I don't want to make. I want to miss on 2 intersects with the chance he makes on 3. And so essentially we're writing down all the different ways he could make a shot on 3. And so, you know, there's only 4. So he could miss his first shot, he could make his second shot, he could make his third shot. He always has to make his third shot for this to be accurate. And then finally he could miss his first shot, he could miss his second shot, and he could dig deep and he could make that third shot. So now we need to actually figure out what these values are. And here we just plug in what we know from our tree above, right? So let's go back up and look at this tree. So we know that make 1 is 1/2. We know that miss 1 is 1/2. We know that make 2, or any makes below that, assuming he made the first shot, is 2/3. And any misses below that, assuming he makes the first shot, is 1/3. And vice versa over here on the first miss. If he misses the first shot, he has a 1/3 chance of making any subsequent shots. And if he misses the first shot, he has a 2/3 chance of missing any additional shots and potentially getting some nasty calls from people in the stands. But we'll leave that how it is. So let's go ahead and plug those values in. So there is a point. Oops, I want to use decimals, but it's much easier on this problem. It may not seem like it to use fractions. So in order to do this, it's just like traveling down the tree, right? It's 1/2 times what's the chance he makes the second shot if he made the first? 2/3 times 2/3. And you know what? I could totally like figure this, but we're gonna just keep it the way it is, and we're gonna go ahead and do some fancy math. And I think you're going to like it. So 1/2 chance he makes his first shot, 1/3 chance he misses the second shot, assuming he made the first shot, and a 2/3 chance he makes the third shot. And then finally, we've got 2 more. He misses the first shot, well, that's a 1/2 chance, times he makes the second shot, that's a 1/3 chance, here on the missing side, times 2/3, oops, times, oh, that was not the button I wanted. There we go, times 1/3, he makes the third shot, and this is assuming he missed the first shot. So again, he misses the first shot times he misses the second shot, that's a 2/3, times he makes the third shot, and that's 1/3. And so what does all of this add up or multiply up together? Well, let's figure that bit out. Okay, instead of doing them here, I'm going to do them down here. And so we have the probability that any third shot is made is equal to 1/2 times 2/3 times 2/3 plus 1/2 times 1/3 times 2/3 plus 1/2 times, wow, I just totally spaced on that, 1/3 times 1/3 plus 1/2 times 2/3 times 1/3. And that's what we figured out up above. So hopefully that made sense. If not, watch it a couple of times, play with the numbers. And so now we're going to put all of this together, okay? Before we get any further, I want to kind of clean this up right here. So this is equal to 1/2. So I can pull out 1/2 from all of these. So I can be kind of lazy there. So we're going to put 1/2. And 2/3 times 2/3 is 4/9. I love multiplying fractions. I hate adding fractions, but I love multiplying fractions. 1/3 times 2/3 is 2/9. And let's see, 1/3 times 1/3 is 1/9. And 2/3 times 1/3 is 2/9. And so this equals 1/2. Let's see, 4 times, well, that's 9/9, isn't it? Or, haha, I love when this happens. 1/2. And it's not always going to be that neat. But problems out of a book, problems out of your tests, often they are just that neat, and we love when that happens. So, okay, so that's our probability that any. So let's go back to our formula. I'm going to just be lazy. I'm going to scroll up here. Oh, where is it? Where is it? Where is it? The probability that he makes his first shot times the probability that he made his third shot over the probability that he makes any of his third shots. So let's see. We decided that the probability that he makes his first shot, well, we know that that's 1/2 times the probability that he makes his third shot, given that he makes his first shot, so that's 2/3 over 1/2. And I'm liking this because I'm going to use a different color just so it's nice and clear. We can cancel that out, and this equals 2/3. And that is the answer for part A. So let's move on to part B, and it's really fun when these are multi-parts with the Bayes probabilities, because a lot of times you can use the same stuff over and over and over again, and I love that because that just makes it that much easier. So let's go ahead and check out part B. So we've solved part A. I'm going to go ahead and label that. Part B, let's go ahead and read the problem and see what we can steal from part A to make this easier. In a game in which the player makes his third shot, find the probability that he made all 3 shots. So we want the probability that he made all 3 shots given that he made his first shot. So that's not so bad. Well, we know the bottom is going to be the same. The probability that he makes any shots, any of the third shots, is still kind of important. So we're going to keep that one in there. That is still our bottom. And so we still know that. And what is that? That is 1/2. And given the probability that he makes all 3 shots, well, we can figure out what the chances are that he makes the probability that he makes all shots. I'm just going to call it that. And so let's figure that out really quick. That's nice and easy. That is, well, if he has a 1 in 2 chance of making his first shot, so that's 1/2 times, if he makes that first shot, which we're assuming he did, he has a 2/3 chance of making the next shot, and then he has a 2/3 chance of making the final shot. And for reasons that will be clear, I'm not going to actually solve that right now, and I'm going to show you why. Oftentimes I like to write everything down and cancel stuff out before I start multiplying fractions, because once you multiply fractions, well, I hope you'll agree with me, they're kind of annoying. And then finally, the other thing is we know that he made his third shot. And we know the probability he made any third shot. But here it's kind of interesting because we know that that's all we need. I'm not quite sure how to explain my reasoning here, so I'm going to actually solve the problem, and hopefully that will help. If it doesn't, as I said, I'm going to do some more of these Bayes probabilities, and hopefully that'll make sense. So we have 1/2 times 2/3 times 2/3 times 1. He made a shot at first. There's a 100% chance he made that first shot. We know he made it, given that he made all 3 shots. So that's why we have this times 1 here. So given that he made all 3 shots, the chances that he made the first shot are 100%. And that's kind of weird. I'm going to be the first to admit. So that's the part that's a little bit hard to explain. And then underneath, well, we have that answer that we had before, which is 1/2. Right? I'm going to go all the way back up here. This is the chance that he made any of the third shots. So again, we can cancel some stuff out. We can cancel out this 1/2. This one, I mean, we don't need to cancel it out. It doesn't really matter. So let's go ahead and solve this. This is 2/3 times 2/3, which equals 4/9. And that is our answer. And so let's step back, and I'm going to walk you through how I solved this. As I said, these are a little bit off-putting, I think, but they're not so bad. So let's go ahead and check that out. So a quick review of what we've done here. Let's go ahead and zoom out and go up to the top. So we read the problem, step 1, always step 1. We wrote down what we know, and the fun part about this one is I wrote it down in tree form. You wouldn't have to, but I think That makes it a little easier to understand. We put down our various probabilities at different stages, and honestly we could have solved this by going down the tree, but we didn't. We used this formula. That's the standard form, and I tried to break this down into what I think of for each of these. And so the first part of the problem, part A, asked what were the chances that he made the first shot given that he made the third shot. So that's, what's the chance he makes the first shot given that he makes the third shot? And that is equal to the chance that he makes shot 1, and so that's 1/2, times the probability that he makes the third shot, which is 2/3. We solved those down here. We knew those. Over the chance that he makes any of those third level shots. And that's what we solved here. And that's what all of these are. Okay? So that is the probability. I'm just going to do one. Probability he makes 1 intersected with the probability he makes 2 intersected with the probability he makes 3. Right? And then this one is, kind of the same thing, only he misses 1. And then this is the opposite, right? He misses the first one, he makes the second one, makes the third one. He misses the first one, he misses the second one, he makes the third one. And we assigned all the values that we knew from our tree to these, and we multiplied them together because that's how you deal with that part of it. And so we figured out the probability he makes any of those third shots is, well, this. And we simplified down, and we got 2/3. Or we got 1/2. And so when we plugged that into our formula from above, we got 1/2 times 2/3 over 1/2. We did some cancellations, and we got 2/3. And so part B was much, much faster because we knew that the probability that he makes any of the third shots is 1/2. That was nice and simple. And we found the probability that he makes all 3 shots, right? We just plugged that in, we found that out. And we knew that if he makes all 3 shots, the chance that he makes the first shot is 100%. If he's going to make all 3, he has to make that first shot. And that's the part, it's always hard for me to explain, and I think it's kind of hard to grok. Play with these problems, try some other ones, it should make some sense. And so once you do the math, you cancel some stuff out, you do some math, you get 4/9, which is our answer. Bayes' probability is largely mechanical. Once you know the formula and how things fit into the formula, you can get the answer. It can be a little tricky though, I'm not going to lie, so play with it, do some work, and hopefully I think you'll find it pretty easy.